Hi everyone, once again welcome back. Today I'm going to discuss intermediate hypothesis testing with you. Okay, so when we conduct testing, there are four possibilities. See, so when we conduct a test, either we reject the hypothesis or fail to reject the hypothesis, right? One first case is reject the hypothesis. Reject if p value is less than alpha, and fail to reject if p value is greater than alpha. Okay, so these are the two possibilities when we conduct a test. But when we fail to reject the null hypothesis, fail to reject H naught, then p value greater than alpha. So fail to reject means we accept, right? Okay, so we are forced to accept that one. When we accept that, two things may happen. What are the two things? We accept that if it is wrong, and if we accept that even if it is wrong. So the second case is we accept that if that is correct. So two possibilities. If we accept that when H naught is actually correct, or that is the first case, and the second case is fail to reject H naught if H naught is wrong, actually wrong. Okay, so there are two possibilities when we fail to reject or accept when it is correct, accept when it is wrong. So these are the two possibilities, right? Then in the same manner, when we reject the hypothesis, the things can happen like that way. So when we reject H naught, when H naught is actually correct, yeah, actually correct means reject H naught even if it is correct. And the second possibility is reject the null hypothesis even if it is actually wrong. So two possibilities for rejecting and two possibilities when we fail to reject the null hypothesis. So that is why I said there are four possibilities when we test a hypothesis. Okay, and we know when we reject the hypothesis, and when we reject the hypothesis and H naught is wrong, there is nothing wrong. That is correct. Yeah, the decision is correct, right? When we reject H naught, actually the H naught is wrong. So the wrong case, we reject that, there is nothing wrong with that one, right? So that is correct. That is correct. And then the other possibility is that this is correct. Okay. And the other possibility is that what? When we fail to reject means we accept H naught even if it is correct. So that is again a correct decision, right? We accept it, it is correct. And we reject it, it is wrong. Okay, so there is nothing wrong with that two decisions. But if we accept the hypothesis, null hypothesis, even if it is wrong, that's an error, right? That is an error. Okay. In a similar manner, when we reject the hypothesis, even if it is correct, even if the value is correct, we reject that. That may be another possibility. That is also an error. So this is also an error. So there are two correct decisions at the same time, two wrong decisions. Okay. So now look back to this table here. Do not reject H naught when it is, means accept H naught when it is correct. That is true. And do not reject H naught when it is false. When it is false means it is wrong, at the same time we accept it. So that is what is called type 2 error. Type 2 error. And similarly, when we reject H naught. If reject H naught, it is wrong. There is nothing wrong. So that is a true decision. And reject H naught, even if it is correct, that is called type 1 error. So this is type 1 error, and this is correct decision. Okay. So there are two types of errors. One error is fail to reject. Okay, sorry. So fail to reject H naught when H naught is actually wrong. So we accept it, at the same time it is wrong. That is called type 2 error. Type 2 error. And what is type 1 error? Reject H naught when H naught is correct. So even if it is correct, we reject it. That is what is called type 1 error. So two types of error, type 1 error and type 2 error. Got it? Now we can conclude that by this way. So what is this? So the decision is not to reject H naught when H naught is true. The fail to reject H naught when H naught is true. That is a correct decision. And reject H naught when H naught is false. That's again another correct decision. So this one. And that the other two are wrong, wrong decision. So that is what is called errors. So reject H naught when H naught is true. Reject H naught when it is correct. That is type 1 error. And usually we denote alpha by type 1 error. So type 1 error is denoted by alpha. Okay. And similarly, the type 2 error, actually the probability of that is denoted. I'm sorry. The probability of the type 1 error is denoted by alpha. So probability of type 1 error. Probability of type 1 error. What is type 1 error? Reject H naught when it is true. That is type 1 error. The probability of that is called alpha. So that is type 1 error. Similarly, the probability of reject the type 2 error. That means the probability of fail to reject when it is false. That is called probability of that type 2 error. That is denoted by beta. So probability of that is alpha, type 1 error is alpha, probability of type 2 error is beta. Okay, and one more term, that is the power of the test, that is 1 minus beta, that particular value is known as the power of the test. Okay, yeah. So alpha and beta should be as small as possible because they are probabilities of errors. So if the alpha and errors should be minimized, so the probability of that type 1 error should be minimum, and probability of making type 2 error is also minimum. That is for a good decision or a good test. Okay, and so 1 minus beta, that is taken as the power of the test. Okay. Okay, and alpha is the significance level. We know the confidence level. If the confidence level is given, we can find out the alpha value, and alpha is called the significance level. Okay, and if you choose very small value for alpha, means what? If you have 95% or 99% of confidence, then the alpha value is, if confidence level is 99, then the alpha value is very small, right? Alpha value is 1%. So if that value is 1%, then it is very difficult to reject the null hypothesis. Reason? You know what is the reason? Because if you have the probability curve, we can see that here the point, the alpha level is 95%. You can see the value there, that is 95%, right? Then the remaining portion of that is 0.5%. That 5% is significance level, that is divided into two portions. So it will be, see, this is 2.5%. So 2.5%, and this is again 2.5%. So you know that is 2.5%. So only 5% is the alpha value. So that alpha value means this is the central value, and we know there is only a less possibility to reject that value, because most of the values are included in that area, because that area is wider. So only 5% is left out. But if we increase that the two sides significance value, then what? Then that value means the 2n level means that the two tails will have only means more area than this one. Just like here, we have only 70% is the confidence level. That means 30% is divided into two sides. So 15 is the, no, 30 is the 30% is the significance level. And here it is just 5%. Here is just 5%, but this is only 5% here. But in this case, it is 30%. So see the area between these two portions, the central area. See, look at this area. This area is less than that of this area. Now we are going to discuss the test statistics and the p-values. So already we know what is the test statistics. That is, z-score is called the test statistics. And you know, if it is a normal distribution, how to find it's a bell-shaped distribution, how to find the z-values. So z-values is given by z is equal to x bar minus mu divided by sigma over square root of n. We know that one. X bar is the sample mean, and mu is the population mean. That means the what is the claim value, that is like that. And sigma is the standard deviation of the population, and if we are given the sample standard deviation, we will take it as the standard deviation, and n is the sample size. So that is what is z. So this is the test statistics c, and it's the probability of z is called the p-value. The probability of that is called the p-value. Okay, p-value is the probability. And in a similar way, we can define the test statistics c for the proportion, that is given by z value is equal to c is equal to p prime minus p divided by square root of p dash q dash divided by n. Okay, so as we discussed earlier, we can see that thing here. Z value is equal to p prime minus p divided by square root of p dash q dash over n. Or sometimes we take it as pq divided by n, the same thing. Okay, p dash means the sample proportion, or the mean value taken from the sample, and p is the population mean, and the probability of that, you know, q is equal to 1 minus p. Okay, and the probability of z, the test statistics, is called the p-value here. The same thing. And how to find p prime? P prime is given by x. P prime is given by x, some number of favorable cases divided by total number of cases. So that is the test statistics and the p-value. And when we find the p-value, if p is greater than alpha, then the probability is more than the significance level. Then we will fail to reject, means accept the hypothesis. In that case, that p, the probability is that p-value will be the claim value. The null hypothesis will lie in between the confidence level, and so that is why we cannot reject that one. And if p-value is less than alpha, the probability less than that of the significance level, then that will be out of the confidence level or the confidence interval. Then we will reject the hypothesis. That is the conclusion that we have always follow that type of conclusion. So p greater than alpha, accept means fail to reject, and p less than alpha, reject the hypothesis. Okay. Now let us discuss a problem here. You are performing a left-tailed test with the test statistics z value. C test statistics z is equal to negative 0.38. Find the p-value. We want to find the probability of that one. For that, we need to take the GeoGebra. Okay, GeoGebra is here, so we can take the value, and the make it sure that it is the normal distribution. So what we want to do is we want to make sure C square means it's the standard normal distribution, that is why mu is equal to 0, sigma is equal to 1, and we want to put that value point negative 0.38. We want to find the left tailed. So negative 0.38 that we want to input here, and then it is the left tail, so we want to hit the first button there, and so that is it. So okay, so probability of that z value, z is negative 3 we can change that to 0.38, 0.38 there. Yeah, that is 0.352. That is the probability of that one. That's it. You just need to hit the first option because it is left tail. If it is a right tail, we want to hit the second one, means the last one. And so here it is the less than value, so it is the left tail, because you know the tail is in the left side. If we hit this one, the tail is on the right side. So that is why. And if you pick this one, you know, it is the this one, it is the two tail test. Okay, so in this case because the tail is on both sides, so that is why. But in this case we want to find the left tail test, and the value is, we want to input that value here, negative 0.38. Yeah, that is 0.352. So the probability is 0.352. Got it? Now let us have one more question. And this question, we have given the test statistics. We have to find the test statistics, the p-value corresponding to that also we need to find out. But we have given the x bar value. X bar is equal to 490, mu is equal to 500, sigma is equal to 25, n equal to 30, right? So we need to find z value. Z is equal to x bar minus mu over sigma over root n. We just need to input that values, 490 minus 500 divided by 25 over square root of 30. You just need to use the calculator and find out the value. And is nothing but negative 2.91. Yeah, we can check that. Negative 2.19. Okay, so if we write it to two decimals, it is negative 2.119. That is the value. And we can find the p value, probability of that. Probability of z is equal to negative 2.19, and it is p value that can be find out using GeoGebra. Okay, so take GeoGebra and input that value and hit the first one, p of x less than or equal to negative 2.19 equals. It is 0.0143. Okay, so that is the value, 0.0143. That is the p value. So we are asked to find the test statistics and the p value. That's it. Okay, and you can also use GeoGebra to directly to find out that one. Okay, and for this we need to find z test of a statistics, z test of a mean. Actually, x bar mu is equal to 500, so we need to input that value there. And it is less than or equal to, because we hit the first one, and mean is 490, and the standard deviation is 25, and the sample size is 30. Okay, that's it. Now we can check that value here. See, its z value is negative 2.19, and it is there, 2.19. And the probability is 0.0143, 0.0142. It's okay. Yeah, that's it. So if you use GeoGebra, it is easy to find out directly the value from that table. Okay, I think that makes sense. Hope that you enjoy the video, and say goodbye. For the time being, we can have more videos in the future. So stay tuned. Bye.